Hi statistics students, this is continuation of summary statistics guided notes. You should have your notes out and you should be on page 10 of those notes, so the back side. We talked about measuring center with the median and the mean. Now we're going to be talking about measuring variability. Now remember, variability is one of those 4 characteristics you should be describing off of a graphical display where you talk about how spread out the data is. And if you're looking at a graph, you're just kind of estimating how much it spreads apart, but there's more ways to do it than just saying the spread. But the typical way you do it off a graph, you're essentially describing the range. Now we technically haven't talked range in this class. We've just walked right up to it and then paused. So the range is the distance between the minimum value and the maximum value. We talked about finding those two values, but we never actually found that distance. We never subtracted them, max minus min. The key thing to note is this is a single number. If you take the AP test, if you talk about how the range of my data values is from 0 to 10, they're going to dock you for that. Range is a number. Your range would be 10. The distance, the spread outedness of your data is 10 units for that example I just made up. So if I'm talking about instead the range of the estimates of the population of Pierre, South Dakota, well, our highest value that was guessed was that 2.6 million person, and the smallest number that was guessed was 4,000. That's not the range. That is how I calculate the range. So if I type that in, because I was too lazy to do that in my head, I get 2,596,000. And that's a pretty huge range when we're estimating the size of a city. So range is a very common measure of variability. Another one is to talk about quartiles. Just like the prefix sounds with quart, you're dividing your distribution, your numbers, into 4 groups of roughly the same size. So it would be like if I lined everybody in this class up and just said, okay, lined everybody up by, let's say, height. And they'd say, okay, you fourth are the shortest 25%, and then the next fourth would be one of the middle 25%, and then the second to tallest 25%, and then the tallest 25%. So you're just chopping your data into quarters. So your first quartile is the value for which 25% of the observations are less than. So you're just lining up all your values and kind of saying, how many did I just do? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You're saying, okay, so here we got 25% less than this number. It's the median of the first half of your observations, which means if I find the median of this data set that is just a bunch of dots right now, and I look at what's left, if I find the median of what's left, that's my first quartile. The third quartile is pretty similar, but it's the median of the second half of your data. So something like here, yes, it's the median of this, but again, you're splitting it into quarters. So 75% approximately of your data, of your observations, are going to be less than that value. So it just has to be an ordered data set, which is why the median is involved, because that's from an ordered data set. But you're finding the median of the median, essentially. So once you have the first and your third quartile calculated, you can find what's called the interquartile range. So it's range. It's a type of range. Therefore, it is a measure of variability. So it's the distance between the third quartile and the first quartile. So rather than saying, oh, my range from here to here is this number, this distance, you're saying, okay, well, instead of all of my data's spread outedness, let's look at this 25% and this 25%, which means the middle 50% of your data. How spread out is that chunk? So it's just giving another breakdown of the spread of your data. So by doing this, we end up calculating what's called the 5-number summary. The 5-number summary will be, where do I want to write this? I'm just going to going to write on the blanks. We're going to find the minimum value, the first quartile, the second quartile, which is the median, the third quartile, and the maximum. So this is just basically saying I have this ordered data set. I got small, first 25%, middle, next 25%, and then the very tippy top. So if I do this for Pierre, South Dakota, I don't really want to order all 34 of those data values. So I went ahead and put them in my calculator, because your calculator can and will calculate this for you if you know how to use your calculator. So again, everybody else, go start Googling. But 83, 84 people, here's a picture of my calculator. I have already entered in our data set. So you can see the 4,000. We could see there was a 0. I'm glad I looked at that. 2.6 million. So we got our data set. And if I want the 5-number summary, I'm going to push Stat. I'm going to go to Calc. And I'm only dealing with one list, one variable, so I'm going to use one var stats. Now, this, I didn't put data in L3. My data is in L1, so I'm going to push second, number 1 to access L1. I did not use any type of frequency list. I just had every number in there once, and I'm going to calculate it. So we see the average that I had shown you before using a Google Sheet. And then there are 34 numbers that I have entered in. There are 34 people who took that survey. And if you scroll down, you get your 5-number summary. That's what I'm going to be using. That's what I'm going to be using here. So the minimum I already knew because I found my range earlier. So I already knew it was 4,000. But this went ahead and found for me the middle of our lower half of data was 12,000. We already found on the other notes the median, the middle value was 15,000. I think we had to average the two middle ones. And then the middle of the top half of our data is 40,000. And then that maximum is our 2,600,000. So that's our 5-number summary. If I wanted the IQR, I want the number that shows how spread out the middle 50% of my data is. It's always going to be, if it's the distance from first and third quartiles, it's always going to be Q3 minus Q1. So in this case, I'm going to be taking 40,000, that third quartile value I just calculated, minus 12,000. And if I take 40,000 minus 12,000, I get 28,000. That's how spread out the middle 50% of our data is. So we know the whole data set spans a distance of 2,596,000. That's a huge spread. But if I just look at the middle 50%, I see that it's only spread out 28,000. This is kind of reflecting the fact that this number is so massive. So we can use this 5-number summary to create a data display called a box plot, sometimes called a box and whisker plot. A box plot takes this 5-number summary and just graphs it. So I'm going to, how am I going to do this? I'm going to make a number line, and I realized later that I tried to print this grid for you, but I think I made it too light, so you might not be able to see yours. Sorry, just try and make them equally spaced. So I'm going to label this as always. You never have an unlabeled data distribution or graph. So these are our population estimates of Pierre, South Dakota. And I need to go from 4,000 to, this is the same problem I had with the dot plot, which is not on these notes, so I can't reference it. It's going to be kind of hard to range that much. I just need to make sure I'm going consistently, so I probably should have looked at this before I started the notes video. Let's see if I can 10, 20, 25, 30, 35, 40, 45, 50, 70, 75, 80. Okay. Let's do, I don't know if I like that. Deciding how to scale your graphs is, for me, one of the most annoying and tedious steps of creating some of these. And I might end up making this whole thing and then not even liking what I chose. And then again, because we have just some wildly varying data values, I'm gonna cheat, and you will never have, okay, I don't say never, but it will be a very rare data set that I will ask you to make a box plot where you have such a huge number compared to the rest. So you will not ever do this. I'm going to do it because I would like to stay sane and save paper and make a legible graph. So I'm going to make an axis break to say I'm skipping over some numbers. This is not to scale, but it's as good as I'm going to get here. So we're going to make a box and whisker plot. So the box part of this is the span that is represented by your IQR. So I'm going to have a box that starts at 12,000. So I'm going to get approximately 12,000. So it's not perfectly accurate. Where would I actually be? Let's see, half of 5 is 12. I'd actually probably be closer here. And then it ends at 40,000, which is way over here. So this is the box part of our box and whisker. So again, this was our Q1 value. This is our Q3 value. The box will always start at Q1 and end at Q3. There is a median in between here, so I'm going to throw a line where the median is. So at 15,000, we can see our median. Now I am labeling Q1, median, Q3 above these. I don't normally do this, but since this is the first box plot you've ever made, that's why I'm putting these labels up here. Then I need to have the whiskers. This is the box, and then I need to say, okay, this is the middle 50% of our data, but it spreads out to the left and right. That 25% of the data is to the left of that number. So that's what I'm going to do. I'm going to draw a line that kicks out to the side, and then sometimes people put like a line like that. Sometimes you'll see a dot. Neither one's right or wrong, but I'm just going to put a dot. And again, this is representing your minimum value. I'm going to do the same thing on the side, and again, this is not all kinds of accurate, but in reality, this whisker should be so freaking long. It should be spreading way out to the right. I just don't have room for that. And I didn't want to change the data set, or you shouldn't just throw out numbers. So the question then asks, is it skewed right, skewed left, or symmetric? Now, let's pretend we don't know any of the data values. I can't go to my calculator. I can't look at individual data values. This is kind of like the problem with the histogram. You don't know the individual data values. So yes, there is a gigantic whisker over here. But for all I know, that means there is one really far out guess, and maybe the rest of my guesses, maybe like 25% of the class guessed 45,000, which isn't super spread out to the right. The problem with a box and whisker plot is you never know for sure where your dots are. You never know, are they all clustered toward the end of the tail, or are they spread out evenly, or are they getting close to Q1? You don't know where they are in the whiskers. You don't know where they are inside the box. If you don't have a data set in front of you, you don't get to know that. So while we see this tail out to the right, and we've already looked at this data set, we can say it is likely to be skewed right. If you are ever asked about the shape of a box plot, never say that it is one shape or another, because you don't know for sure. So I'm just going to put don't know for sure. without seeing the individual values. That 2.6 million is really messing with us. And it is a very high estimate, and I keep referencing it. If that was your guess, don't feel bad. I'm really glad that this is part of our example. Yes, it makes it a pain to try and graph, but it really helps illustrate some of the properties we need to look at. But it's not really close to the rest of the class's guesses. So it's likely to be an outlier. Now, we don't just say, oh yeah, that one's far away, let's just call it an outlier. There's an actual test for this. You need to call an observation an outlier if it falls more than 1.5 times the IQR. So more than 1.5 IQRs above the third quartile or below the first quartile, which means we have our box defined here. We just want to say, okay, here's this distance. Don't go too far away from that distance. You can go a bit far away. You can go 1.5 times, but pretty much anything beyond that is just getting a bit too far, and we're going to classify it as an outlier. So a outlier on the left, a small outlier, will be found by taking whatever the number is for your first quartile and subtracting that distance, subtracting 1.5 IQRs. I'm just going to keep using multiplication symbols here. An outlier on the right, what we think we probably have with that 2.6 million, will be your third quartile plus that distance of 1.5 IQRs. So you're basically trying to say, let's take this distance of 1.5 IQRs and just tack it left and right, subtract from the Q1, add to the Q3, and see if you're outside those fences. Every time you ever do a box plot from here on out, you need to check for outliers and you need to show your work. Again, stats is really big on the AP test, and therefore I will be as well, about I don't really care about the answer as much as the process you took to get to the answer. So we're going to look for it in this example with our estimates. And we're going to look for any outliers. So I need to know my IQR, which we said earlier was 28,000. So I'm just going to note, so I don't have to keep scrolling up. The IQR was 28,000. The first quartile value was 12,000 and 40,000 for Q3. Okay, so I'm first going to find 1.5 times my interquartile range. I need to know what distance I'm saying is acceptable for our values. So I'm going to take 1.5 and multiply by 28,000. And I'm getting 42,000. So a low outlier will be any number that's smaller than Q1, 12,000, minus 42,000. If you go 42,000 to the left of the beginning of the box, that's going to be too small, and we're going to call that a low outlier. So for this problem, a low outlier is going to be some negative number, which, thank goodness, none of you guessed a negative population. Good job, guys. So if somebody had guessed something smaller than negative 30,000, we'd say that's an outlier. That's too far from everybody else's guess. So let's check for a high outlier. We didn't think we had a low outlier, but there's a real good chance we got a high outlier. So I'm going to check for that. So it's going to be anything bigger than, I'm out of space, sorry. I'm just going to throw it down here. So a high outlier will be anything larger than 40,000, the end of the box, plus that acceptable distance of 42,000. So our high outliers, and I say plural because you can have more than one high outlier, is anything more than 82,000. It's basically saying, based off of what most people were guessing, middle 50% of the guesses, if you go more than 82,000, you just guessed an unusually high number compared to everybody else. So when I actually go back to looking at the data, which is here, I already have it sorted. When I go look at those numbers, there are 2, 3, 4 outliers, which is really interesting actually. There are 4 guesses that were higher than 82,000. So I'm going to go back and amend that that box plot. It's going to be kind of difficult, but I'm going to manage. So, crap, this is going to be really difficult because I didn't make it big enough. I'm trying to think what I'm going to do. I'm sorry. I'm going to make life difficult for your notes, and I apologize for that. Actually, wait, let's undo that. Let's duplicate it. I'm going to throw it here. So I'm going to shrink it down so that, oops, not that. Let's shrink it down so that I can actually continue that to the right. And I get that's going to be really hard for you to do on your notes. I apologize. Okay, so I'm just trying to keep going so that I can get to 50,000. 55,000. 60,000. 65,000. This is probably a good reason for me personally to start breaking these videos into more than one video, because then I could just go back and redo one part, but I am way too deep into this video now and I'm not about to redo it. So you guys just get to suffer. I'm mostly sorry. And then we're going to cheat again at this point. Okay, so I said earlier that any number more than 82,000 was a high outlier. And then I looked at my data and I found 4 of them. So I'm going to put 4 dots that will not connect to your box and whisker plot. So I said 84,000 is an outlier. So this is, I'm just going to label it to help make your understanding hopefully clearer. So there's a dot for 84,000. There's a dot for 90,000. And even though I redid some of this graph, I still am not about to go out to 400,000. So there would be way on down the line a dot at 400,000. And again, even further beyond that would be a dot at 2.6 million. So if you were the person who guessed 2.6 million and you've been feeling bad about your guess because I keep calling you out as being very high and pulling your data to the right and all that good stuff, you're in good company, because 4 of you guys guessed a very large number, but again, only large with respect to the rest of your class. However, these are outliers. They do get separate dots like this, and yes, these ones should be way further to the right than I have them, but I'm cheating. The other thing is that whisker has to end somewhere. Right now I just kind of have it floating in the middle of nowhere. So what you do with the box and whisker plot is you basically check for outliers, which I did, and then basically say, okay, well, that's an outlier. Let's not use it as the end of the whisker. It's not a good maximum. That was an outlier. I don't want to use it as a maximum. Outlier, which means 70,000 is going to be our new maximum, because we don't want to ignore the outliers, but at the same time, we don't want to confuse them as being typical values. So this 70,000 is functioning kind of as a new maximum. Now I'm putting this in quotes because if I ask you what the maximum of this data set is, do not tell me 70,000. But it's going to be kind of like it because these outliers are just not typical values based off of the rest of the estimates given. So we'll just end the whisker at 70,000, the next highest number once the outliers are removed. So this process of finding these are called fences. So sometimes you might hear me refer to them as that. Finding what you cannot go beyond without being an outlier is important every time you do a box plot. So in class, we're going to do more box plots. So you're going to get practice on this again. But I did want to go all the way through this one. And sorry for not doing it in advance and making